Hello and welcome to my presentation on how to implement OPC for machinery in one day. My name is Wolfgang Mahnke and I'm working for Unified Automation, and we have toolkits and infrastructure around OPC for example, the UA GDS for managing security certificates of OPC applications. We also provide SDKs, software development kits for implementing OPC applications. Um, this will be the focus on this presentation, so I will show how to implement the machinery specification. In order to do that, I will first shortly introduce you into the machinery specification. So the general idea of the machinery specification is we do have domain-specific models for specific domains like geometric measurement systems, pumps and vacuum pumps, compressed air systems, flat glass processing, tightening systems, machine tools, woodworking machines, and so on. And they all have different models, which makes a lot of sense because they do different things, but they also do have things in common, and those common things are defined in the machinery specification as a common model for the domain machinery. We have so-called building blocks for different use cases. So we have use cases which can be applied everywhere, like the identification of a machine or of a component, a high-level state of a machine. We have more specific things like the job management, so that an MES system can push a job to the machine. The machine executes the job and sends back results, the status of the job, the results, quality data of the execution, and so on. And companion specifications or vendors, when they implement an OPC server, can pick and choose what building blocks they actually want to support. Um, I will focus on three of those building blocks. One is the identification. Based on the devices specification, we have some extensions for machines, so it does provide things like a product instance URI, a globally unique identification of a device, or in our case a machine. We have extensions like the year of construction, more specific for machines. It can be applied for machines and components. There's a bunch of information which is provided by the machine vendor or the component vendor. We also have capabilities where the system integrator or the operator can add additional information. That's the identification of machines. We have machine monitoring, so we want to know what's the status of our machines. Are they uh, in a good health condition? Are they executing something at the moment? So therefore, we have the machinery item state. Here in our example, everything all uh, is green, so everything is executing, but could also be that they are not executing because there is no job order, for example, at the moment, or material is missing or whatever. It could also be out of service or not available, in the sense that you don't have the information at the moment. Um, this information is known by the machine, so the machine knows if it's executing or not. There's also another state, the machinery operation mode. Um, this is typically not directly known by the machine, but needs to come from the outside world, either by a local HMI or by an MES system. And you can say, oh, I'm actually doing something productive. That's what you want to achieve mostly. So you're processing. But you can also say, oh, I'm maintaining the machine, but I need to execute the machine while I'm doing the maintenance, so to check that everything is okay. Or during setup, you sometimes also need to execute the machine. And those two states combined you can use to do KPI calculations. So here in the example we have 8 hours. We're looking at 8 hours where the machine is supposed to do processing, but actually it's only happening in 5 hours. There it is executing, with 1 hour where it's not executing. So maybe some material is missing or didn't get a job order, whatever, and 2 hours it's out of order. And with those informations you can, for example, calculate the availability of the machine. The job management, the idea of the job management is I have an MES system managing jobs, and I have machines which are supposed to execute the jobs. So the MES sends a job order to the machine. It may send several job orders. the machine, whenever the machine is ready, it picks one of those job orders based on some internal logic and starts the execution of the job order. The MES system get notified if this is happening. The MES system might get intermediate results, and when the job execution is done, there are some final results with does include quality data or bill of material and so on. And we have a mechanism in here that those data don't get lost, so they are very important data sometimes. There's a mechanism that the machine keeps the data until the MES system actually clears the result, and then the machine knows that they have been processed by the MES system. That's in a nutshell the machinery specification. When you want to implement the machinery specification, there are different options. Um, Two high-level options, of course, there are variations of this. The first option I captured here is you implement the machinery specification in a PLC, so a machine has one or several PLCs, and modern PLCs all have capabilities to have an OPC interface from a PLC vendor, so you can put the functionality on the PLC. The pro is obviously you don't need any additional hardware. You can just use the PLC you have anyhow. You just program your PLC. You don't need to implement your own software. You don't need to maintain that software. And this is actually relative easy to do, of course, depending on the tool chain of the PLC vendor, but it's relative easy to do for simple things, like, for example, the states and the identification we have seen. It's much more challenging for more complex things like the job management, and in the end, you're limited to what the PLC vendor provides you in terms of OPC functionality. How much functionality you get depends, of course, on the PLC vendor and also on the version on the PLC. Uh, but very typically, not all OPC functionality is available on a PLC. An alternative implementation is you do your own implementation, you develop your own software on top of a machine. The software runs typically in an IPC. You can use an SDK and code generation to do that. That makes it relative easy to implement this for simple and also for complex things. And by using reasonable SDKs like the ones from Unified Automation, you have all the OPC functionality available. There are some architectural advantages with this, so you don't put additional load on your PLC, so you make sure that the PLC doesn't get overloaded and can focus on its closed loop control. Um, you can address security, access restrictions, and so on in the IPC. You just block completely the access to the PLCs from the outside world. Everything goes over the IPC, the scaling, and so on. That approach also works in brownfield when you have PLCs without OPC functionality, or the very first PLC supporting OPC had very, very limited OPC functionality. So also in those cases, you can use that approach. And this is the approach I will focus on the rest of the presentation. So we're doing this with an SDK of Unified Automation, of course. We're using the .NET SDK, and the idea is our implementation runs on an IPC. The machine provides some kind of .NET interface we can access from our implementation. In our example, it's a simulation, but it could also be an extraction to access a real machine, for example, via OPC or whatever kind of communication mechanism. We're implementing parts of the machinery specification. We do implement the identification, the states, and the job management. For the identification, there are a bunch of constant things which will never change, like the manufacturer, and you can put those already into the model itself. So in the UA node set, this is where the model is stored, and then instance dependent information like the serial number typically would come from simulation, or you would configure this in your IPC. the states, the machinery item state, so if the machine is running or not, obviously needs to come from the machine, so in our case from the simulation. The operation mode, typically not from the machine. In our case, we have an OPC method so that either a local HMI or an MES system could set this operation mode. Job management, obviously the machine needs to execute the job, so the machine is implementing a very simple job management where it just takes one job order in and um, and executes that job order, and the rest of the job management is implemented in our IPC, where we manage that several jobs can come in, that they may be run several times, and we do this. We store the results until they get cleared from the MES and so on. So the more complex part is done in our implementation then, and doing this in a high-level programming language like .NET is by itself, I would say, easier than in a PLC, and you have all the infrastructure and we have the code generation and so on. Our approach is we have our tool, the UA modeler, for creating information models. So we need to create a project in the UA modeler first. Then we're loading all the companion specifications we want to use, like the machinery basic building blocks, the machinery job management, companion specs which are used by those, like the devices specification. Those companion specifications, or more precise, the UA node sets of those, you can download from the OPC Foundation webpage, from GitHub, or from a cloud library. We load them into our project. We create our own model on top, creating our own types, our own instances. And after we've done this, we can use the code generation of the UA modeler. It's available for all our SDKs. So we have SDKs in various programming languages for various environments, like also for very small embedded devices, where we have the high performance SDK and so on. We will focus on the .NET SDK. So we do generate code in this case for the .NET SDK. And the only thing we need to do is now implement the data binding. So we need to get the data out of the machine and into our information model, and the logic, like doing the job management, the higher level requirements there, and all the other stuff is already in the generated code. And finally, we need to compile it, and then we're done with our server implementation. Of course, in this approach, we do support round trips, so you can change your information model still, and we have mechanisms that if the code gets regenerated, you're not overwriting your own code. We use partial classes in .NET, for example. We have implementation classes and so on, that you're not destroying the code you have generated. I will do a small demonstration on that. So we're using now the UA modeler. We don't have so much time, so I've prepared something already. Um, Here is the UA modeler, and all the companion specifications are already loaded into this one. I have created already, in this example, a table machine type, and the type is using the identification of the machinery specification with product instance URI, manufacturer, and so on. The job management, and we have the machinery item state, the machinery operation mode, and this method to change the operation mode. And what we're still missing, and that's a little bit I want to do, is create an instance. So in the machinery specification, you're supposed to put your machines under the machines object, and I'm doing this, just adding an instance of the table machine type, and maybe call it my machine. And by doing this, I'm creating an object here in my information model, having all the infrastructure in place, as you've just seen on the type. And just to show this, for the manufacturer, for example, this is typically static, I can put in my company there, and I can store this, and then I can use this for code generation. So I'm just need to click on this one here, and then in the background some files get generated, and while they get generated, I can already um, run to the output. So you see here a Visual Studio project has been generated for that, and I'm just opening that one. Um, and before I go into the code, and I'm not going deep into the code, let me first run it. Um, so starts on a different screen. So here my server is already running. I haven't touched anything in that server right now. And I have here a UA expert running, which is pre-configured to be connected to that server already. And you will see here, oh, my machine is already there. And you can go to the identification and see, yes, this my company is already there. So all the stuff is in place. But of course, things like the serial number, I haven't added there. So the data binding still needs to be implemented. Um, but this is nothing we will do. We don't have enough time for that. Um, However, I want to show you very short overview of the code. You can see for each information model there is an own folder, and for uh, my own information model I have here. So for all the object types, you have a file having corresponding .NET classes, and for all the types you have created. And you can see here, here's my table machine. And if I open that one, go to the public properties, you see, for example, here's the identification. If I go to the identification, I can go to the serial number and now set the serial number and grab the information just um, from my machine. All the infrastructure is in place. You just need to fill in the data. Um, with this, let me go back to my presentation. So you have seen this now also, and a little bit of code. So you can see here in the example, the identification serial number. So it's very easy to access that stuff. It's very much how uh, you would do it in a programming language. So this is how our code gets generated. You can fill in the information there, which comes in this case from our machine simulation. For the states we have, we didn't go into this detail. There are state machines behind, and all the code for the state machines is also generated. So you really just need to go and set them here in the beginning for not executing, for example, for the machinery item state. And you can see on the button there is the set operation mode method. So this is all the stuff is already generated, and you just need to fill the logic. And this is in this case just changing the operation mode, and that's because we have so much generated code around. That's really very easy to do. Just that you get an idea when it's getting a little bit more complex in the implementation of your server. Let's take a look into the job management. So I have a client, I have an OPC server. You can see this iMachine is part of the OPC server. So that's the interface into the real machine. The other logic is implemented in my server in the IPC. So if the MES system sends me a job order, the first thing I'm doing is I'm checking, is this a job order I can execute? If yes, I store this in the OPCUA information model so the client can see now that it has been added. And then the logic starts, oh, I can execute something. There's a job order. Maybe I want to execute it. Um, then I start the execution. Then also it starts to be represented in the results. Of course, I don't have any results at the moment, but I need to start the execution really in the machine. And then I get intermediate results out of the machine. And in the end, the execution is done. I can access all these parts of the information model from the MES system, and when this thing is done, of course it's only the data are still there, but it's not getting executed anymore. Then you can clear this again, and then it goes away. And this is not just working with one job order at a time, but the MES system can stand several job orders. So one gets started, I'm sending more and more. They get executed. The one is finished. The next one starts, and the next one starts, and this is how it's done. This is a little bit on the implementation behind. I'm not going into code or anything like that, but what I want to do is show you again a small demo. So I have, let me see, the server's not running anymore. I have here a server which is actually implemented the logic of everything. And this is running now, and I have a client which I've created also with code generation and then made yeah, let's say very ugly user interface, but it's working nevertheless. And you can see here the server is not doing anything at the moment, but I can connect to the server, and then I can say, oh, maybe I want to have a job which I want to execute 3 times. I want to create maybe 5 shelf floors and 1 table leg or something like this. So you can configure this obviously. And if I send the job order, you see the simulation in the background is actually doing something. You can also see here there's a status of the job order. It's ended now, and you could see here in the progress now it's the end result. But if I start it again and maybe a couple of times, you see that one is running, others are ready to run, and you see intermediate results, how many things have already been created. That's already sent to the client, and the client can display that information. And at some point it's done, and you can also clear all the job orders when you're done. And this is in a nutshell what's going on there. Of course, you can also use a more generic client to look into that server implementation. So I'm just using the UI expert again. So you can see now here's a serial number which I got from my implementation, from my simulation. Um, I can also go to the machinery item state, and you see it's not executing at the moment. I can go to the machinery operation mode. It's currently set to none. That does not make too much sense. So I'm changing this with this method call to processing, hopefully. And you see this is changing. And um, if I start a bunch of job orders again, you see we're now in the executing state. I can also go to the with the events. I can see here, oh, some jobs have whenever the status of the job is changing, I get an event, and I can see that information here as well. So this is a very short demonstration of the job management. Going back to my presentation, that was a demonstration I've shown. And to summarize, first, what are actually the benefits to implement the OPCUA for machinery specification, or the building blocks we have used? The machine identification, you have a unique identification, which is the foundation. So a globally unique identification is very important. It's a foundation for asset management. The machinery item state and operation mode. First of all, you have a high-level state. Is the machine executing or not? And you can use this as base for KPI calculations. So you still need to do the calculations on top, but this is the base to do them. With the job management, the MES can bring job orders to a machine, and it can receive the job responses, including the quality data. And the whole big idea of the machinery is, of course, this is standardized across all the machines of your machine pool for different types of machines. It doesn't matter. You can always use the same interface to do that kind of stuff. To summarize this, the foundation is the OPCUA for machinery specification. We have building blocks for various use cases. When you want to implement them the way I've showed you, you have the UI modeler for tooling, you load the companion specifications, you pick and choose what you building blocks you want to do, create your own machine-specific model, and then you can do the code generation for the unified automation SDKs. The generated code is already out of the box running, and you have a server providing you the information model, but you need to do the bind the data from your machine that the correct data is shown, and you need to implement logic like for the job management and so on. The title of the presentation is How to Implement OPCUA for Machinery in 1 day. So obviously I cannot really show this in 20 minutes, but I can show this in much more detail, that you actually can start doing your own implementation in a day. If you want to figure out, we're providing actually trainings for exactly that, and then not for 20 minutes, but for a whole day. Next dates, it's always online. Next dates are on the 24th of June and then on the 9th of December again. If you want to figure out more details about that, you can go to our webpage, unifiedautomation.com. And of course, there you also get information for our SDKs and other tools we have around OPCUA. With this, I'm at the end of my presentation. Thanks a lot for listening and have a great rest of the day.